we're looking at question number 5 right now. And with this question, there's actually 2 ways of doing this question. You can use calculus, or if you remember, you can also use pre-cal. Okay, so I'm going to do calculus here. The calculus way is going to take us a while. But we will still get the correct answer, and you'll see that the pre-cal is much faster if you have that information. So here we have some curve. We know this is a rational function, and we're trying to find where it's concave up. So concavity, so the key word is concavity. I'm going to put concavity. T is the second derivative test. Okay? Why? And then we need to remember some basic information here, not vocabulary. So when the second derivative is greater than 0, this means it is concave up. When the second derivative is less than 0, it is concave down. Okay? So we basically want to find here, and we want to find where it's concave up. So we're looking for this here in this problem, folks. So we need to find the second derivative and find where it's greater than 0. Okay? So we're going to do so. We're using the second derivative test. So step 1 with this is we need to find the points of inflection. Okay? Where are the points of inflection? Points of inflection is where the second derivative is 0. Or D, N, E. Right? So we're going to find that now. So before we find the second derivative, we have to first find the first derivative, right? And our function is again given here. So I'm just going to write this. So y equals 1 minus x over x minus 3. So I'm going to first find y prime. So y prime. So I'm going to use the quotient rule low. D high, the derivative of this is negative 1, minus high, D low, this derivative is 1, all over low low. So then we get y, I'm going to simplify. Remember, sometimes you want to simplify, sometimes you don't. Because I'm going to take the derivative again, you want to clean this up because it just looks really ugly right now. So we're going to get, distributing this, we get negative x plus 3, right? And then this is 1 times anything is anything, so this doesn't change. I'm going to distribute the negative. Minus 1 plus x here. I distributed my negative here. All over x minus 3, the quantity squared. Okay? And now we're going to continue simplifying. Y prime equals. So if you notice the x's go away, and I'm just left with 3 minus 1, which is 2 over x minus 3, the quantity squared. Okay? Cool. So this is my first derivative, so now I need to find the second derivative. Let's go ahead and do that. So you have a couple of options with the second derivative here. I think it would be easier to rewrite and use the power rule, but I'll go ahead and use the quotient rule since most of us are like it that way. So y double prime is derivative, low is this here, times the derivative of this. The derivative of a constant is 0, minus high, D low. So I'm going to write this derivative out here, times the derivative of x minus 3 squared all over low low. So this is to the 4th power, right? Because when you square a square, you get to the 4th, right? Now, this derivative here, do this off to the side. So if you know how to do it, just keep going. So this is basically the power rule. The derivative of blah blah squared is 2 times the blah blah times the derivative of the blah blah, right? And then my blah blah is this one, x minus 3. That stays. And the derivative of this is just 1. So it just stays as this over here. So this becomes this piece here. Okay? So what we get then is y double prime equals x minus 3. Wait, sorry. This is 0. Just cross that out. And we end up with minus 2 times. This was 2 times x minus 3 here. Okay? Remember, that was this here, right? We put this guy in for here, for this derivative of x minus 3, the quantity squared, all over x minus 3 to the 4th power. So what we get is negative 4 times x minus 3 all over x minus 3 to the 4th. If you notice, one of the x minus 3's goes away. So we get negative 4 over x minus 3 to the cubed power. So now we want to find where it's 0 and does not exist. See, the issue with this is, if you set this to 0 here, you can clearly see that there's no solution. Why? Because if you multiply by the bottom, you're going to get negative 4 is 0. That's no solution. So this here, we're out with that one. So we have to find where it does not exist. And you can clearly see here, the second derivative does not exist if x. So if x equals 3, then y prime does not exist. This implies x equals 3 is our critical value. So this one works here, right? The D and E one works. So we're going to check now. So we know that x equals 3 is a point of inflection. A point of inflection, if you recall, is where the concavity changes. So we're going to make a number line test now. Remember, we're doing the second derivative test, okay? In the second derivative test, you're going to test it into the second derivative, right? And what is the second derivative? Where was it? We found it. Oh, here it is. We're going to put them in here and just pick numbers around here. So this goes like 0 and what, like 10 or whatever, right? All right, so if you plug 0 in here, you want to simplify. Remember, you're just looking for the sign, right? So I'm going to do it. The pre-cal side won't take us long. I'm going to infringe on its territory here. So we got negative 4 over 0 minus 3 cubed. This is, and notice, look, I'm not even calculating. This is negative on top. A negative cubed is still a negative. Negative over negative, positive. So here, this is positive, which means this is concave up, because the second derivative here was positive. Now we got to check 10, because we cannot assume this is negative just because the first one was positive. So I'm going to plug in 10 here. So 10 minus 3 cubed. We're just checking the sign. So this is negative over, that's 7. Cubed is positive. Negative over positive is clearly a negative. And this is negative, so this is clearly concave down. So what does that imply then? So if you remember the problem, we have to find where it's concave up. Clearly it is concave up from here to 3, so it's from, and if you remember, this one is open, right? So it's from negative infinity to 3. So you look at your answer choices. Which one says that? It says x is greater than 3. That's not true. It's not this one. It's not this one. It's not this one. So x is less than 3 is correct. That's where it's concave upwards. So now we can do it very quickly with pre-cal, if we remember our graph. So if we remember this graph here is this one, right? If you rewrite this to look like this, you know you have a VA at x equals 3. And you know it's going to look something like this, right? Now, if we remember from last year, what does a negative do? It reflects it over the x-axis. So if I flip this, you're going to flip this one around. So basically, it's going to look something like this. Whoops, I messed up. It's going to look something like this, right? So where was the VA? It was at 3. So it looks something like this guy here and this guy here. So you can clearly look, where is it concave up? It's concave up from negative infinity to 3, right? So you could have actually done this problem within a few seconds if you recognized the graph, which is why we studied them so much last year. So the answer is E for this one.